Hi guys, and welcome back to the channel. If you've watched my videos before, you'll know that in the past I have built DIY electric bikes, even using a car alternator as a motor. If you're interested in that sort of thing, then go back and check out my videos. In this one I am trying to build an electric car. It's kind of the next step up, and doing so by taking the guts out of a Nissan Leaf, and this is the inverter from a Leaf, and that's the drivetrain from a Nissan Leaf, motor and transmission, and trying to put them into a Land Rover Freelander. In the last video I think I showed you the motor running with an e-bike controller, which is only 800 watts, so just powerful enough to run the motor on the bench. But at least it proved that the motor was spinning and it was a bit of fun. This time we're going a bit further, and we're using the actual Nissan Leaf inverter to drive the motor using this little circuit board, and I'll go into the details of that in the video. So like I say, if you're interested in EVs or DIY stuff, then this is hopefully will be of interest to you, and thanks for watching. Hello guys, and welcome back to a very big moment for me. What I have done here is I have connected up 16 or 15, can't remember which, 16 I think, 12 volt batteries, wired them all in series to give me about 200 volts, which should be enough, I'm told, for this inverter to work. I don't have it connected yet. As you can see, this is the wire that will be connecting the 200 volts to the inverter. I have the neutral connected, so basically the batteries come along here, link up and go back across. So that's where you get your 200 volts from. And what I've done is I have linked the negative, which is coming along the top, which is going down, and it's going directly into the inverter through one of these, I can't remember what you call those type of plugs, but anyway, the negative is in directly to the inverter. The positive comes down on just a bit of flex, goes into here where it junctions out. One side goes through these resistors, which are each of them about 5 ohms each. They're labelled 4R7, if you can see that. But they're actually measuring about 5 ohms, so between those resistors, there's 6 of them, there's about 30 ohms there. And I believe the Nissan Leaf pre-charge resistor is 30 ohms. So anyway, half the power comes through here and into this switch. And I would like to be able to tell you that this is not an old cooker switch, but that's exactly what it is. It's an old cooker switch. And if you look on the other side here, when you turn this knob, you see different of those contactors flick in and out. And what I've worked out is that at this point everything is off. If I turn it to the left once and then again on the second turn, sorry, I'll do that again. Turn to the left once and this contactor goes, which, sorry, it does. Okay, we'll start that all again. Turn it once and a second time, and this contactor on the left, the far left, will close. And if I close it, turn it one more, turn to the left, one of these should go in and the one over here should stay in. And if I turn it again, then this one comes off. So what I'm going to do is have the pre-charge going through on this first pin, and the main voltage will be coming through. I know it's a black wire, but it's actually positive will be coming through on this pin. So turn 2 clicks, pre-charge on. Turn 1 more click, main main voltage is on directly to the battery, so it's not going through the pre-charge. And at this stage, the pre-charge is still on. 1 more click, pre-charge is off. So that's the plan. I haven't powered this on yet, so this is going to be my first time doing this, and we're about to find out live whether or not I'm going to blow the crap out of myself. So first thing we'll do is turn this back to off. Everything is off. Put the click key back on here, and then hopefully you can see that okay. Right, first thing I need to do is, I'll just turn you around a wee bit. First thing I need to do is plug in the 12 volts, which is somewhere. Here's the 12 volts. So we've got ground and 12 volt battery and 12 volt primings. So they will all get plugged in now, and that will put 12 volts to the Damien Maguires VCU. Now I haven't tweaked this, I haven't done anything at all to it. This is exactly as it came from Mr. Maguire. So as you can see, we've got lights flickering, lights on, so that should be okay. Double check we're still off. Yes, we are. 200 volts. Let's see what happens, boys and girls. Nothing should happen here. Good, nothing happened. So we should now have 200 volts here. Let's flick at the first click, nothing should happen. And on the second click, we should get, now this is fused, but that should give us, we should now have 200 volts going through the pre-charge resistor. So I'll just double check that. We have 200 volts. And now I put the next click, and that should have brought in the other contactor. Let's go back, yes, just double check. Now, if I put my foot on this throttle, something should happen. Nothing happened. Right, okay, we'll have to go back and check what's going on. Get the laptop connected to this, and we'll see what happens. Always a bit of an anticlimax. Oh well. Back in a bit. Right guys, this is attempt number 2 to try and get this thing to work. We still have the VCU board. It's connected slightly differently this time. What I've got is I've got 12 volts going to the VCU continuously, just from this battery, going to the VCU continuously. The 12 volts that goes to, which is on these 2 wires, which goes to the inverter, goes through a switch. You can just see there, it's just a rocker switch. It's only 12 volts, so there's no danger of doing any harm. So 12 volts goes to that. That's how that's what you would sort of consider as an ignition switch. Also coming off that is an input wire going to the VCU now. But I didn't realize this the last time, but input 1 has to go live, has to go 12 volts to basically turn the ignition on and enable the VCU to spin, or to spin the motor. Let me see, what else have we got here? Green wire. Yeah, it's just so basically treat this as an ignition switch, turns on the inverter and also turns on the VCU. So basically the inverter has 12 volts at all times. So the other thing I've changed slightly is that I've got this just sitting up here so that I can manipulate it by hand. I'm still using a cooker switch to switch on the 12 volts, or sorry, the 200 volts. Switching 200 volts through, initially through these resistors to prevent any spark. When there's massive big capacitors inside any inverter, and if you just put 200 volts to it, you would get an almighty bang as those capacitors initially behave like a short circuit and then suddenly charge up. And if you're very lucky, you'll not blow something, but if you're not, you will. This is the connector for the throttle cable. That just is, yeah, it's just coming around here, and you've got negative, positive, and sensor wires. So that's basically it. I need to now plug in my 200 volts over here, which I'm doing gingerly, as you can see, but there you go. So the 200 volts is connected, so now we have 200 volts coming to this switch bank, but as you can see on the meter, there's nothing has come through to this yet. So cooker switch has to be turned, and ignition switch has to be turned on. So I don't know if it really matters which order you do this in. So I shall turn this on first of all. And if I turn that once, click, nothing should happen. No voltage, that's fine. Second click, we should get 200 volts. So that's now 200 volts going to the inverter through all these resistors. So now I want to disconnect those resistors and connect the 200 volts directly into the inverter. So just click one more click. That's actually put the 200 volts to the inverter directly, but the relay, the resistors are still in the circuit. So just second click, and that's them. So now we have 200 volts going directly from the batteries into the inverter, and the switch, the resistors are not involved anymore. As you can see, we've still got 200 volts, 204. So I need to flick the ignition switch, and there's a slight difference in the lights on the VCU. And oops. That's slightly different to what happened last time. I did this once before, and maybe because I have only one of the one pedal of the connector of the throttle pedal connected. But anyway, look, we're getting places. We've got spinning motors at 200 volts. So yes, I've only got one of the inputs from the Leaf pedal connected. So I'm now going to connect the other one. See if that makes any difference, that the two of them then work in sort of together. And I've also got some software to change in this to tune the Leaf pedal in a little bit. So yeah, the other thing is when the motor is off load, there's nothing to bring it back down again basically, so it will spin a lot faster and with less control than if it's on load. So I'm not worried, I'm happy. It's working well. It's working. It's getting places. I know this looks like an awful mess of wires, but you just do one at a time. a lot of them aren't even being used. So we've got it working. We've got spinning motors. I guess the next thing is to start ripping the engine out of the Freelander so that I can get the gearbox out, so that I can figure out what size to make or what length to make the coupler using some of this, which is cold drawn steel, 45 millimeters external diameter, 35 millimeters internal diameter, and approximately the right size for the clutch discs that I have. So that'll be for another night, but it's really good to see this working. Very pleased. So anyway, that's it. We'll mess about a bit more and hopefully tune it a bit more, and we'll get back. Hi guys, well, I've made a little bit more progress here. As you can see, I've taken hopefully you can see it over there, the Nissan Leaf cable throttle pedal is gone, and in its place is the throttle pedal out of the Freelander. I kind of figured there was no point in really spending a lot of time trying to get the Nissan Leaf throttle pedal working when this is the one that I want to use anyway. So that's in. I've done a little bit more tweaking of the system using my trusty old laptop, and we have got somewhere. We still have a problem, but I have a notion of what it might be. So first of all, what I'll do is I'll turn it on. This is basically turning on the ignition, and as you can see on this occasion the motor didn't go mad. And if we go over here and touch the throttle, we have some degree of control. And if I was to push that down a little bit further, the motor continues to run even though I've let go of it, and it even starts to get slightly faster. And if I touch it again, it gets faster again, and so on. And it's not actually the speed isn't dropping down. To get this far, I've had to tweak the settings in this. I'll just knock that off. That's just turning off the ignition basically. To get this far, I've had to change the settings in the code for this particular VCU. I've reduced the torque setting right down to something like 15 so that I could get some control. Basically because there's no load on the motor, the torque that's required for that is absolutely minimal. So I've reduced the torque down to something like 15 or 20, and it was by default I think set to 2000, something like that. And I calibrated the throttle cable, and there's a procedure for doing that, so I managed to achieve that. Like I say, we're very close. We're getting some sort of control here, but the speed just is continuing to ramp up every time I touch the throttle. I'm thinking it might be down to an earthing issue, and in as much as I haven't got any earth connections anywhere. So I'm going to start strapping earth leads to between different between the motor and the inverter at the very least, and possibly also then to the throttle pedal, and we'll take it from there and see what happens when I've done all that. So when I've done that, I shall come back. Okay guys, well it looks like I think I may have actually got this thing cracked. Earlier I was struggling to get the motor to slow down, and I think it may have been, I think I said it at the time, I thought it might have been an earthing issue, but I actually think the problem is the lack of load on the motor. The inverter obviously needs some kind of a pushback to get it to shut down or to turn off. So what I've got at the moment is I have the original Nissan Leaf transmission with the electric lock taken off, and there's a spline here. Turn it one way, it makes a clunking noise, and that's it unlocked. Turn it the other way, it's it locked. That's just like a transmission lock. Basically, it's the same as putting your automatic car into park. So that's what that is. I had to take that out, crank that round to unlock it. I've gone back to the original, or not the original, the newer version of the software, which is version 1.5 or something like that. Something like that. Can't remember. There it is there anyway. But anyway, I've done that. I've put in the approximate codes for the throttle. It's probably not perfect, but at this stage it doesn't need to be. This is my Freelander throttle pedal. So I have the ignition turned on that switch. The inverter is still connected to the laptop, but that doesn't matter. I'll just go back to that. And if I start to push that throttle cable, you can hopefully see that spinning. That would be spinning the drive shafts if they were plugged in. And up here you should be able to see the RPM going up. And more importantly, coming back down again, which wasn't happening earlier. And the only thing I've changed is I've put a load onto the motor by connecting it to the transmission. So I'll give a rundown of the connections the way I have it set up. I have about 19 batteries here, giving approximately 245 volts, something like that, DC. The throttle, as you can see, it's just a standard. Land Rover Freelander throttle pedal, and those just happen to be the pinouts that I need for it. Took me a while to figure out which pins to use, but those are the pins that I'm using. The top one is pause for, usually these throttle pedals are TPSs, throttle position sensors, or the other name for them. These throttle pedals have two Hall effect sensors in them, and at the moment I'm using the one which gives the higher voltage. There's another one which gives a slightly lower voltage, and the car monitors the difference between those two throttle Hall sensors to confirm whether or not the pedal is good and operational or not. So if you've ever had a TPS fault in your car, it's probably one or the other Hall sensors has gone. That's just connected into the VCU. The VCU has some of the connections coming from this connector into the inverter, go into there. Other ones go into the resolver, which is down there in the motor. I have the three phases, which hopefully you can see in there. Maybe not, it's a bit dark, but anyway, the three phases are connected in there and just come out via this heavy duty 3-core cable and go down and just plug on here. So the three phase wires, which are probably pretty high voltage, so I need to be careful of those. A fairly high AC voltage, so that's what that is, and that's the resolver plug. So that's how it's all connected up. It's not difficult to connect up. It's not difficult to do any of this stuff. It just takes a lot of figuring out. But that's a very nice thing to see in here. And you can hear that's slowing down. It's slowing down quite slowly because there's a very low load on it, but it is slowing down. I don't want to mess about too much with this because there's no oil in the gearbox. And you can see the RPM just falling down slowly on the screen. I'm not entirely sure that's real time, but anyway, it seems to work. Yeah, it seems to be a bit slow coming down. I presume that's the temperature inside the motor and the inverter. They're both sitting about 11 degrees because it's quite cold here in mid-October. So, looks like it's working. I think I'm happy enough now to move on to phase 2, which is stripping down the car. That's a fun stage. So basically you can put all this back on put it all away again and start stripping the car down. Get the engine out, get it all nicely cleaned up. If you're wondering what things like this is, that was a wire that was being used for the second sensor over here. I don't actually need it, and it's just I'm just using it as an earth now. Basically all of the negative wires are all hooked together and eventually head back to the 12 volt battery, to the negative of the 12 volt battery. So we're running. We have a spinning motor and I am very pleased. It's been a long time getting this far. The other thing of note has happened just yesterday was the Nissan Leaf that I bought was taken away on the back of a lorry to a scrapyard to be stripped of all its parts, and I no longer have it anymore, so I'm pleased to get rid of that, and I even got some cash for it, so that was a big plus. So that's us done for now. There's not a whole lot more I can do. I guess the next step is to put this throttle back into the Nissan, into the Land Rover Freelander, so that I can move it about again. And yeah, hey, that's a big step forward. Hope you've enjoyed this, and any questions, sure, post them down in the comments below. So thanks for watching. Bye for now.